फिर से सुना ही नहीं है। प्रीवियस स्क्रीन बोल रहे हो क्या? हाँ दिखाता हूँ, 1 मिनट होने दो ये न्यूमेरिकल।
यस सर, बट इसमें कुछ दिया नहीं है ना कि यूनिट मतलब कितने डेसिमल थी।
Yes. Yes, 2.68. 2.68 is correct.
बट सर इधर तो ऐसा कुछ दिया नहीं
हाँ
है।
मेंशन नहीं किया, भूल गए होंगे वो। हाँ हमारी ट्रिक गड़बड़ हो गई ना। But in maximum cases you will get this instruction, okay, up to 2 decimal place. Wow, I don't know why here is not mentioned.
जनरली सर फिर 1 या 2 डेसिमल तक ही लिखना पड़ता है ना वैसे भी।
हाँ नॉर्मली 2 डेसिमल। अब नहीं है, इफ यू करेक्टली नो दी फॉर्मूला और आंसर आ ही रहा है तो आप वैसे ही लिखो, ओके।
यस सर।
और जब गेस करते हो या फॉर्मूला नहीं मालूम तो इन दैट केस थोड़े थोड़े हिंट दिखना पड़ता है। So here you know the formula, you can directly calculate with the help of formula. 2.68 Newton per mm square. Okay, so again फिर भी मुझे आंसर किसी का ही नहीं आया। अच्छा वो अप टू 2 डेसिमल पे इसकी वजह से कंफ्यूज हो रहे थे क्या? Okay, so formula is 2p pi dl. Okay, so 2 multiplied by, okay, again one problem is here, pi की वैल्यू भी मेंशन नहीं की है। Okay, so in such a numerical you will get very big range, okay, so that all the possible answers are correct. So 2 multiplied by p, p is given 5 kilonewton. Okay, so I will put 5000 newton. Okay, because I need final answer in Newton mm square divided by pi dl. Okay, so I will use 22 by 7 here. Okay, 22 by 7 multiplied by d, diameter 27, radius is given, okay, 27 mm. So double कर देंगे, we will get 54 mm. Okay, multiplied by pi d l. L is again thickness is given 22 mm. Okay, so 22 mm square. Okay, तो unit आ गया. Okay, so you can calculate this numerical with the help of unit also. Okay, very easy if you don't know the formula. Still you can calculate with the help of unit. Yes, but ये दो हम guess नहीं कर पाएंगे. So 22 by 7 कैंसिल होगा क्या? नहीं होगा. Okay, मैं ऊपर डाल देता हूँ इसको. So 22 multiplied by 22 multiplied by 54, 2636, 10,000 multiplied by 70,000, 2636. Okay, so 2.67, okay, or 2.68. Okay, I will write 2.68 after rounding off. Final answer. Clear? Any doubt?
Thank you, sir.
Next is flexural strength. Flexural strength. Okay. Now this strength will comes in play when we need to construct any beam or we need to check the strength of a beam. Okay. जो हम कंस्ट्रक्शन में बीम्स यूज करते हैं ना, ओके, स्लैब वगैरह डालने के लिए, फॉर दैट बीम यू नीड टू चेक दिस फ्लेक्सुरल स्ट्रेंथ. Okay, this is what we are doing. We are using a cuboidal blocks. Okay, your beams. Sorry, I will use cube here. Okay, sustain. Okay, so we are putting that particular rock like this. Okay, like this. Now we are okay. दो सर्कल के ऊपर बीम को रख दिए. This is actually your basement. Okay, this is actually basement. Okay, and this middle one is your sample. Okay, this middle one is your sample. Okay, now two circular blocks are used. Okay, to balance the beam. Okay, and now we are applying pressure from, we are applying vertical pressure. Okay, okay, so here actually we are looking for transverse strength. Okay, what we are looking for, transverse strength. So if you are searching for bending loads, okay, you are looking for bending loads. Okay, just like we need to construct the beams. Okay, so you need to check whether it withstand particular pressure or not. Okay, otherwise ये bend होगा या break down हो जाएगा. Okay, for this reason we are doing this, because in construction what we are doing, okay, ऐसी, sorry, ऐसे beam लगाएंगे. Okay, now this beam is balanced with pillars like this. Okay, so instead of the pillars we are using here circular blocks. Okay, at the ends of the beam. Okay, and now we are putting pressure at the center from vertical downward. Clear? Like this. So here two blocks are exerting the pressure from downward. Okay, on the beam and from the above. Okay, so 3 points are applying the pressure. Clear? So this is called as 3-point load. This test is called as 3-point load. 3-point load. Clear? This 3-point load. कर लिया ड्रॉ?
Done, sir.
Now again we have one more 4-point load. Okay, एक से पहले दो. And this is your basement. Okay, we have like this. Okay. This is your basement, or you can say foundation for this particular test. Okay. Now this is 4-point flexural strength test. Previously we have seen 3-point test. Okay. So here you can see 1 point. Okay. 2 point, 3 point, and point number 4. Okay. So this is your 4-point flexural.
तो इसके पहले वाले में हमने जो टॉप प्रेशर था उसको भी कंसिडर किए थे, तो फिर तो इसमें 5 होना चाहिए ना, क्योंकि उसको टॉप प्रेशर कंसिडर करके 3।
नहीं तो जो ऊपर वाला है, okay, here P is on this beam. Okay, actually we are looking for this beam. Okay, this is our sample,
ओके
not this.
ओके गॉट इट। ओके थैंक यू।
Okay, actually we are looking for this sample. Okay, I will use star mark here. Four-point flexural. Yeah. So again we have formula for both 3-point and 4-point. So first write here formula for 4-point, sigma f. Okay. F representing flexural strength. 3PA divided by BD square. Okay. Again, P is the load at failure. Okay. A is your area. B is your width. Okay. Now this is in cuboidal shape. Okay. So you need to consider the formulas for cuboid. Okay. If you need to calculate the volume, then use L into B into H. Okay. If you are looking for surface area, then you should go for formula of surface area. Okay. Twice L plus B plus H. Okay. D thickness. Okay. B is your width and D is thickness. Okay. Not diameter. B is your width and D is your thickness.
तर सरफेस एरियाचे काय फॉर्म्युला म्हटलं?
Twice bracket L plus B plus, sorry, thumb million. D is your thickness. LB plus BH plus H. Okay. इथे ठेव. Okay. See, basic mensuration के सारे formula आपको, you need to learn all the formulas. Okay. Mensurate for your ore geology actually. Okay. If they are saying your ore body is in cuboidal shape. Okay. So in that case, you need to calculate the volume of your cuboidal ore body. You should know this. Okay. At least volume. Clear? Next, formula for 3-point. Okay, 3-point load. Sigma F is equal to 3 PL divided by twice BD square. Okay. L is your length.
सिग्मा टी आहे का?
Yes. काय?
तो सिग्मा टी आहे का?
Sigma F. Flexural strength. Clear? Again, next property. Okay. Now we'll look for elastic properties. Okay. Elastic properties of sun. So we already studied about elastic properties in structural geology. Okay. And we'll again use the same formula, that is modulus ratio is equal to E divided by UCS. Now you will tell me what is E.
Unconfined compressive strength.
E. I am talking about E. Asking about E. Sorry.
Elasticity.
Extension.
No. Okay. Think about the first numerical. Okay, we already used this formula in first numerical. याद आ रहा है?
Young modulus.
Yes. E is your Young's modulus. Yeah. E is your Young's modulus. Unconfined compressive strength UCS and modulus ratio. Okay. You know the formula for E or for Young's modulus? Sigma upon E. What is sigma and what is E? ये तो रिवीजन है. ओके. ये सब हमने we study all these parameter symbols in structural geology in quite detail.
E elongation.
No.
Strain as strain, sir.
Yes, strain, correct. Stress and strain, correct. Sigma is your stress and E is your strain. Okay. So Young's modulus is the ratio of stress upon strain. Clear? This is your actually stress upon strain. Stress upon strain. Clear?
Yes, sir.
Based on this formula, एक numerical हम पहले ही कर चुके हैं. Okay, we already done the numerical. Next is your mechanical properties. Here we'll see first attrition test. Attrition test. Okay, now you know the attrition. What is attrition? For this test we use Devil's testing machine. Devil's testing machine. Okay, what you will do? Okay, what is the attrition? Tell me first. What is attrition?
Mutual collision.
Yes, mutual collision. Okay, so what we do? We'll put the sample. Okay, in particular chamber. Let's say this is your chamber. We put the sample in particular chamber along with the other rock fragments. Okay, along with the other rock fragments. Okay, and we'll rotate the chamber. Okay, so many times. Okay, so that all the rock fragments and sample can mutually collide with one another. Okay, and after doing particular rotation, some number rotations are fixed. Okay, or duration is fixed. Let's say we are rotating for 1 hour. Okay, so after that we'll collect the sample. Okay, we know the, yes, like a ball mill. Yes, Paranda. Okay, and after the particular rotation or after the duration of particular time, okay, we'll collect the sample. Okay, now we know the quantity of the original sample जो हमने रखा था. Okay, and we'll find out the remaining sample. Okay, if your sample is lost more than 3%, okay, then if rock it is not good for any construction. Let's say if your rock is lost more than 3%, okay, of your, or your percentage of loss is less than 3%, then rock is good for any, you can use that rock particular as a building stone or for construction material. Okay, so a loss due to attrition and wear, if it is less than 3%, is good. Okay, and if it is more than 3%, then it is unsatisfactory. Okay, so again we have formula for attrition test. Percentage of wear in attrition. ओके, वियर एंड टीयर मतलब तोड़ना मरोड़ना जैसी एक्शन. ओके, वो वाला वियर है. समझ में आया व्हाट वी आर डूइंग? ओके, सैंपल लिया, एक चेंबर में रखा, उसमें और ब्रोकन फ्रैगमेंट्स रख दिए और उसको घुमाते गए, रोटेट करते गए, तो वो टूट जाएगा बिकॉज फ्रैगमेंट्स विल कोलाइड विथ वन अनदर. ओके, देन कैलकुलेट, देन आफ्टर द रोटेशन विल कैलकुलेट द लॉस. Okay, if it is more than 3%, then it is unsatisfactory. If it is less than 3%, then it is good. Okay, then you can use the rock for your construction activity. So percentage of wear in attrition is equal to m1 minus m2 divided by m1. Multiplied by 100. Okay, m1 is your original weight, okay, and m2 is retained material, okay, means weight of the sample after the attrition, after the rotation. Okay, so you can say retained weight. Okay, m2 is your retained weight, m1 is your original weight. Okay, so you should divide with the original weight. Okay, clear? m1 m2 clear हुआ?
Yes, sir.
सर
Yes.
सर एट्रिशन के कारण अगर रॉक का लॉस होता है तो सर उसकी जो स्ट्रेंथ है उसमें तो कुछ ना कुछ इफेक्ट आता है ना, तो फिर वो बिल्डिंग स्टोन के लिए कैसे क्या गुड है?
तो वही तो देख रहे हैं, अगर लॉस ज्यादा हो रहा है तो हम उसको यूज ही नहीं करेंगे. थोड़ा लॉस हो रहा है, ओके, whatever, let's say you are using granite, okay, it is very stronger rock, good building stone, okay, but still weathering and erosion will happen on granite. Okay ना, बराबर है.
यस सर.
So actually we are checking his that particular resistance of that particular rock, okay, by doing this iteration test, because it is subjected to weathering and erosion. Okay, just one second. दिख नहीं रहा. Okay, leave it. I will share numericals in that. Okay, so this is about iteration test. Okay. Next is Los Angeles abrasion test. What is abrasion? Abrasion.
Friction between sediment and bedrock.
Okay. So now bedrock. Okay. So now we are rubbing the sample against the bedrock in abrasion. Okay. So procedure is same, but instead of bedrock, we are using steel balls. Okay. So we'll put the sample. Let's say this is your sample. Okay. This is your sample. Let's say S. Then we are using steel balls in the chamber. Okay. Steel balls and rock fragments. Then again we are rotating the chamber. And looking for the loss of the sample. Okay. So if you need to use particular rock for the construction of road, let's say, okay, तो रोड के लिए अगर यूज करना है तो क्या होगा, कंटिन्यूसली उस पर टायर घसेंगे. Okay, so in that case you need to you'll check for go for abrasion test. Okay, in that case if you need to use particular rock for the construction of roads. Okay. So again, लॉस एंजल्स अब्रेजन वैल्यू. ओके, टेस्ट की जगह वैल्यू कर दो इज इक्वल टू m2/m1 m2 डिवाइडेड बाय m1 मल्टीप्लाई बाय 100. दिस योर फॉर्मूला. ओके, अप्लाई percentage Los Angeles abrasion value is equal to m2/m1 multiplied by 100. m1 is again your original weight. Okay, and m2 is your retained weight. Okay, so larger the value, weaker is the rock. Okay, so in this case, okay, up to 50% is permissible. Okay, if loss is up to 50%, okay, we can consider good quality, not accident. Okay. Okay, now solve this note. Question number 9.
%73.
73.
ओके सब लोग 73 आंसर कर रहे हैं, थोड़ा सोचो तो। "73 is wrong." See, observe here. 4800 is your initial weight. Okay, no doubt. This is your M1. Okay, but after the test, the aggregate weighted 3504 gram. ओके सो इसमें तो सारा सैंपल आ गया ना, जिसमें हमने फ्रैगमेंट्स भी कंसिडर, वी ऑलरेडी कंसिडर्ड फ्रैगमेंट इन दिस पोर्शन. ओके सो व्हाट इज रिटेन्ड वेट? ओके what is retained weight here? You need to subtract this 3504 from 4800.
नहीं समझा सर.
Actually, though, the original formula for attrition, you need to use that formula. Okay. For retained weight, what you will do? You will do M1 minus M2. Then you will get retained weight. Okay. Divided by M1 multiplied by 100. ओके बिकॉज हमको क्वेश्चन में रिटेन्ड वेट नहीं बोला है, एग्रीगेट वेट बोला है. एग्रीगेट मीन्स व्हाट इज एग्रीगेट? व्हाट इज एग्रीगेट?
Overall.
Combination of so many things. Okay, aggregate is combination of so many things. Okay, so retained weight is not mentioned directly. Okay, so if retained weight is not mentioned, what you will do? You will first subtract, okay, for it or original weight, aggregate weight from original weight. Okay, now will you get answer? कितना आ रहा? 27%. Correct. Clear? So read the question carefully. Okay. Very silly mistake, but 2 marks चले जाएंगे. You will lose 2 marks with the silly mistakes. Okay, this is the basic formula for attrition test and Los Angeles abrasion test. Okay, both are similar. Procedure is similar somewhat. Yes. Okay, just due to because of the rolling mechanism, you will lose some sample. Okay, that is the reason. Okay, they are different. Clear? आ रहा है सबका 27%. ओके M1 is 4800 minus 3504 divided by 4800 multiplied by 100. Okay, you will get 27%. Okay, so here this M2 actually is not given directly. Okay, next is toughness test. Toughness test. For this we use aggregate impact test. Aggregate impact Now in this case we'll consider the aggregate. Okay, again we'll exert pressure on the aggregate, okay, by rolling between the fragments or by impacting with some objects. Okay, and we'll test the impact value. Okay, we'll go for impact toughness value. Impact toughness value, again formula is same, m2 by m1, m2 by m1 multiplied by 100. Clear? Just like loss abrasion test. Okay, but be careful about m2. Okay,
सर यहाँ पे M2 एग्रीगेट इम्पैक्ट टेस्टर रहेगा ना, एंड लॉस एंजल में M2 रिटेन वेट था.
नहीं यहाँ पे भी वो रिटर्न वेट ही रहेगा.
फिर सर हाउ कैन वी डिफरेंशिएट?
वहाँ हम in that previous example in that previous example, okay, we are talking about sample. Okay, now here instead of sample we use entire aggregate. Okay, broken fragment. Okay, so here m2 is your retained weight of aggregate, not the sample. Clear? This test is only useful for aggregate. Okay, next is resistance to abrasion. Okay, for this we have Dory's abrasion test. Coefficient of hardness is equal to 20 minus in bracket loss of mass in gram. Okay, divided by 3. Okay, resistance to abrasion process. Okay, means we are actually looking for hardness of the particular sample. Okay, clear? So what we have done here, we studied all the possible tests and the formulas. Okay, from all the possible test, okay, 3-4 tests are मतलब अब तक आ चुके हैं. Okay, you have seen the numericals from 3-4 tests. Okay, so remaining formulas are also used, very much important. Okay, for gate people. Okay, so the very basic engineering geology is in syllabus for jam people. Okay, so for jam people ये टेस्ट को ज़्यादा फोकस करने की ज़रूरत नहीं है. Okay, you should have best basic idea about this. Okay, in engineering geology you will study means you will focus on that dam tunnel part. Okay, जो बाकी इसके बाद होगा. Okay, so this is all about the test. Okay, various tests and their formulas. Okay, by which we can calculate and we can gather information about the strength of the rock, tensile strength of the rock, hardness of the rock. Okay, stress and strain conditions. Clear? Now our last parameter is rock mass rating. Rock mass rating. This is the final and very important parameter. Okay, now this rock mass rating consists of 6 different parameters. Okay, it includes 6 different parameter, or you can say 6 different studies. Okay, after doing all 6 type of studies, we'll give a final conclusion about the particular rock. Okay, so it includes number 1 UCS. Okay, uniaxial compressive strength. Okay, and you know how to calculate UCS. Clear? Okay, then number 2 is your RQD. Clear? You know how to calculate RQD. Okay, I just simply add 2 more formulas for RQD. Just wait. You know the basic formula for RQD. Okay, RQD in terms of velocity of waves. Okay, VF VF square. Okay. Second. VF square divided by VL square, or you can write whole square for both, multiplied by 100. Okay, so VF is your velocity of P wave. Velocity of P wave in feet. VL is your velocity wave in lab. And one more formula. RQD is equal to 115 minus 3.3 JV. Here your JV is joint volumetric count. Okay, so joint volumetric count means in a particular rock sample, you will count the number of joints.
सर जेबी यूनिट आहे का?
नाही जॉइंट काउंट करा तुम्ही in particular sample. Okay. Two additional formulas for RQD. Okay, done.
सब.
Number 1 is your UCS. Okay, then number 2 is RQD. Okay, number 3, spacing of discontinuities. Spacing of discontinuities. So you will see the discontinuities, how they are placed. Okay, they are very close, okay, or they are far away from one another, like this. Okay, so this will give you an idea about particular discontinuity is nothing but breaks in the rock. Okay, so we'll search for spacing of discontinuity. Okay, if they are very closely spaced, means what you can infer from this condition, if they are very closely spaced and so many discontinuities, okay, you will understand the rock is under great pressure. Okay, and rock is quite weak and is not able to withstand the particular pressure. Okay, clear? Like this. Then number 4, condition of discontinuities. Okay, first you will check the spacing. They are closely spaced or separated from or far away from one another. Then you will go for the conditions of discontinuities. Okay, it's like they are very small, very big, highly fractured. Okay, like this. And number 5, groundwater condition. Okay, check the groundwater conditions. Okay, means you can see the porosity, permeability. Okay, from which you can come to know about the groundwater condition as well. And next, orientation of discontinuities. Okay, so here discontinuities means all the weakness or all the weak spots. Okay, if you smaller fractures, micro fractures, micro faults in rocks, all these parameters. Okay, so they are not good for any sorry, means that rock is not good for any construction activity if it is having very closely means so many discontinuities. Okay, orientation. Okay, what you can infer from orientation of discontinuities, let's say, okay, this is your rock. Okay, so you are getting all the discontinuities in this direction. Okay, they are oriented like this. Okay, so what information you can gather from this such condition?
We can say that the forces or pressure were acting particular uniaxial
Yes.
direction.
Okay, you can calculate the direction of pressure from the discontinuities. Clear? You will get a rough idea about the pressure. Okay, direction of pressure. Clear? Like this. Yeah. Okay, so in rock mass rating, we need to study all these 6 parameters very thoroughly. Okay, and by studying all these 6 parameters and their values, okay, will give your our final conclusion. Okay, and that combined study is called as rock mass rating. Okay, so final conclusion is like, okay, we need to draw one table for that. 6 columns, 5 rows. Okay, here you will write RMR. Mass setting. Okay, then here class description. सॉरी, एक रो कम कर दो. स्टैंड अप टाइम. Okay, stand up time. Here 100 to 81, 82 to 60, sorry 61, 60 to 41, 40 to 21, less than 21. Okay, here 2, 3, very good rock. Good rock. Fair rock. Poor rock. Very poor rock. Okay, so your stand up time is 20 year, 1 year, approximately 1 week, approximately 15 hours. Minutes, like this. Okay, so we'll do this study for any construction or any big structures before construction and also after the construction. Okay, for monitoring purpose. Okay, so if you are getting RMR between 80 to 100, let's say 81 to 100, you will say stand up time is 20 years maximum. Okay, but still you can find so many dams which are standing or working more than 50 years, more than 100 years. Okay, like Three Gorges Dam, China. Okay, Idukki Dam in Kerala. Okay, and you'll find so many examples. मतलब उनका लाइफ हो चुका है. They will, they will collapse anytime. Okay, but we are monitoring them. Okay, and doing whatever we can uh, to stop the any hazard. Okay, so monitoring is very much important. Okay, so if you are getting some cracks or fractures somewhere, then you will reinforce them. Okay, you will seal the cracks. Okay, with you will make the foundation more stronger by grouting. Okay, grouting means we'll pour the cement slurry in the foundation. That is called as grouting. Okay, and we have some methods. I will give you a rough idea. Let's say this is your hill. Okay, okay, and you are getting fractures. Let's say like this. You have such fractures in your heel. Okay, so what you will do? You will go for bolting. Okay, like this. जैसे खिला ठोक देते हैं ना, same process like a nail. Okay, we'll insert the bolt. Okay, at particular spot. Okay, to hold the rock. Okay, this is called as bolting. Okay, if your foundation is weak, then you will pour cement slurry at the foundation. Okay, that is called as grouting. Okay, and in beside the roads in hilly terrains, okay, you will observe some nets are placed. Okay, net लगे रहते हैं कई कई जगह पे. Okay, that nets are used. Okay, they'll place some nets. Okay, over the, okay, that nets are used to avoid the rockfall. Okay, some smaller hills are covered with nets. Okay, to avoid the rockfall. Okay, तो rocks जो है rock fragments रास्तों पे ना आ जाए. Okay, okay, that net will avoid the rockfall. Okay, so that you can safely go from below or from the roads. Okay, or you will see some retaining walls at the boundary of the hill. Okay, you will see some cement retaining walls at the boundary. Okay, mostly in the hilly terrains. Okay, घाट पे देखना, जब घाटी वाले रास्ते से आप जाते हो, you will see some retaining walls. Okay, so यहाँ से कुछ गिर भी जाता है. Okay, तो यहाँ से क्या करेगा, उसको रोक लेगा at some extent. If it is that movement is in small scale, then these walls are useful. Okay, but if movement is like slumping, okay, so these walls are not useful. But ये wall लगाने से पहले we are going for stabilization of particular hill. Okay, like this. So many engineering structures we are using to make the particular hill stable. Okay, so ऐसे ही कुछ processes we are using for older dams. Okay, we continuously monitor the dams. Okay, and we'll do the improvement techniques. Okay, according to the required condition. Clear? So this is about the okay. This is actual engineering geology. This is actual engineering geology that we need to do, okay, for any before any particular construction. Yeah. So this is actually the rough idea, okay. But in actual means in the field you need to go for more intense studies, okay. Some other advanced studies are also will go for other advanced studies in the field, okay, other than this is actually textbook studies, okay. Some laboratory methods, okay, and based on all these studies will write your final report about the site or about the availability of the construction material, what kind of construction material we should use, like this, okay. Clear? Okay. So tell me the number of tests. Okay, first compressive strength, okay, UCS किया, okay, first unified unconfined compressive strength, okay, then confined compressive strength test, okay, CCS, then point load strength test, then Schmidt hammer strength test, then shear strength test, okay, no, sorry, ring or punch shear test, okay, then shear box test, then tensile strength, in tensile strength, dog bone test, okay, then Brazilian test, then for flexural strength, okay, flexural strength किसके लिए useful है? It is only useful for, okay, like if you are going construction of beams, okay, for beams. Then about elastic properties, okay, your modulus ratio, okay, Young's modulus. Then in mechanical properties, attrition test, Los Angeles abrasion test, toughness test, and resistance to abrasion, okay, Dory abrasion testing, coefficient of hardness in Dory's abrasion testing machine. Clear? All these are the important and famous test, okay. फिर भी, but still you can get some new test and new formulas, okay, from some research work or research paper in GATE, okay. तो ये तो करना ही है और बाकी कुछ भी आ सकता है, okay. We cannot predict exactly, okay, if some new invention is there, okay, we don't have any idea about new research in this particular test or finding in some UCS, okay. तो ऐसे भी कुछ हो सकते हैं, okay. We'll again solve some numerical in the end, okay, or in the we'll see some numerical in the test, okay. Like I will show you one numerical here because we have time. Just 1 minute. Okay. So try to solve this question number 51. First Google the formula, okay. First Google the formula, then try to solve the numerical. हाँ, खुद से भी सॉल्व करते आने चाहिए ना. You will not get every formula in your textbooks, okay. Now here the Q value as per Barton's Q system of rock mass classification according to study year 1974, like this, okay. So ऐसे कहीं से भी कौन से भी ईयर के फॉर्मूले आ सकते हैं, ओके.
सब इस टाइप के क्वेश्चंस को कैसे टैकल करना?
कर ही नहीं सकते.
So,
we are helpless in such type of numericals.
so,
In only gate, okay. Numericals in JAM exams are predictable. Don't worry.
so,
Yes.
सर ह्या क्वेश्चनचा हा न्यूमरिक फॉर्म्युला आहे का? Q equals to RQD upon JN into JR upon J into JW upon SRF.
Yes. मी करवला आहे वाटते.
नाही सर, ते रॉक टनलिंग इंडेक्स वाला फॉर्म्युला आहे ना?
फॉर्म्युला हाच आहे.
त्याच्याने येईल सर.
सांग एकदा थांब, मी इथे लिहून देतो. सांग बरं. Q value is equal
RQD
to
upon JN.
RQD, okay, upon
JN
JN, okay. Joint set
into
number multiplied by
JR
JR
upon J.
Where is JR? Yes, joint roughness number divided by
J
J
into
JA sir.
JA, हाँ, yes,
हाँ सॉरी J सर JA
multiplied by
JW upon SRF.
JW upon SRF.
SRF.
Yeah. Now you have all the values. Just substitute the values and calculate. Okay. And for chemistry numericals, I already told you about the, okay, some basic chapters of chemistry, that is electrochemistry, thermodynamics, ideal gas equations, okay, means solution and colligative properties. Okay, these three lessons are very much important. Okay, you will see one or two numericals from chemistry in GATE exam. Okay, and 2 marks numerical in your JAM exam compulsorily.
28 is our answer.
Yes,
28.
So,
yes.
सर मी तुम्हाला एक व्हॉट्सअप केला होता ना क्वेश्चन स्ट्रक्चरलचं, त्याच्यामध्ये ते
मी एक काम करतो, मला खूप लोकांच्या क्वेरी आहेत अशा. आता आपला सिलेबस संपला, मी काय करतो, स्ट्रक्चरल जिओलॉजीचे ऑल डायग्रामॅटिक क्वेश्चन क्लब करतो, त्याचा आपण एक क्लास घेऊन घेऊ. Okay, we'll study all diagrammatic questions of structural geology in one class. Okay, after few days. Many people have doubts in diagrammatic questions of structural geology.
Yes, sir, solving your structural के.
ये कंप्लीट होने दो, इंजीनियरिंग जियोलॉजी एंड सम. ओके, फिर जाम का खत्म हो जाता है और मुझे थोड़ा टाइम मिल जाएगा, है ना. मेरे को अरेंज करना पड़ेगा सारे क्वेश्चंस, सारे पेपर्स में से निकाल के. Okay, so we'll do one session on this, all the diagrammatic questions of structural geology. Okay, now we have plenty of time for JAM as well as next 1 month, okay, for doubts and tests. Okay, so try to study as much as possible. If you are studying, then you will face some difficulties. Okay, then हमको बताओ. Okay, discuss all the difficulties with us, then we'll arrange some extra classes and we'll solve all the difficulties possible. Okay, the reason behind showing this type of numerical, that you should be aware of such questions. Okay, such question will go tangentially. Okay, because such questions are from research or research papers. Okay, or some questions are from research oriented studies. Okay, so if you know the professor who is preparing the particular GATE exam, okay, so at least he will explain such techniques to his students. Okay, only few students are able to tackle such type of questions. So let's say if IIT Bombay is preparing the or hosting the gate, okay, तो हो सकता है वहाँ का जो इंजीनियरिंग जियोलॉजी का प्रोफेसर होगा उसने जो जो चीज़ें पढ़ाई होगी उसमें से आ सकते हैं 1-2 क्वेश्चन, नॉट कंपल्सरी बट पॉसिबिलिटी है. ओके, बिकॉज वन पीपल इज नॉट रिस्पॉन्सिबल फॉर एंटायर पेपर. ओके, एक कमिटी होती है, कमिटी डिसाइड करती है, उनको भी नहीं पता रहेगा कौन सा फाइनली आने वाला है, वो अपने अपने सजेशन देंगे और क्वेश्चंस देंगे एक बंद लिफाफे में. Yes.
Sir, can we have such type of numericals in JAM also?
No. जैम के न्यूमेरिकल प्रेडिक्टेबल होते हैं. मैं वही बता रहा हूँ, पिछली बार के एग्जाम में 17 न्यूमेरिकल एज इट इज जो हमने किए होते उस टाइप के थे. कि ऑब्वियसली वैल्यूज आर डिफरेंट. ओके, तुम भी थे लास्ट ईयर का पेपर चेक करो. ओके, ओनली 2-3 न्यूमेरिकल्स. दिस केमिस्ट्री के थे 2 न्यूमेरिकल, उसमें से भी 1 या 2 न्यूमेरिकल जो अलग आए थे. अब केमिस्ट्री पे भी मैं फोकस नहीं कर सकता, बट यू कैन you can revise your basic chemistry knowledge of 12th standard. Okay, only you need to revise 3-4 lessons: electrochemistry, thermodynamics, solution and colligative properties, compulsorily for 2 marks maximum. उसमें भी थर्मोडायनामिक्स हमने मेटामॉर्फिज्म में कर लिया है. ओके
सर, गेट में हमेशा